Hello, here we are again. You will be pleased to know I have still got the same whiteboard pen as yesterday, and I have even brought some tissues so I don't have to use my sleeve, because if you were using your sleeve in school to rub your whiteboard off, I probably would have told you off, so I probably shouldn't be doing it. But oh well, let's move on. Now today we're going to be carrying on, as I'm sure you have guessed, looking at percentages, fractions and decimals, and we're getting a little bit trickier again today. You'll notice each day we just step up that difficulty ever so slightly. Now, you know what the next slide's going to be? It's going to be the same as always. Here are your imposters. Here are your weird alien things. Have a look through. I, again, am not going to tell you how many imposters there are, so pause the video now, see if you can work out which ones are the imposters. Off you go. Okay, and you're back with us. So, I'm going to start like I always do. I'm going to work along. So I'm going to start top left with grey. Now 66 times 21, they're saying is 1,386. Well, let's find out. So I'm going to write my question down. 66, 21. We have here. We start at the bottom here. We do 1 times 66 is nice and easy. That's just going to be 66. So I can put that down straight away. Now, I'm going to move on to the 2, but it's not a 2, it's a 20. So we need to put a placeholder down here before we even start. Now we do 2 times 6, which is 12. Put the 2 down, carry the 1. 2 times 6 again is 12. Add the 1 is 13. 3 goes there, 1 goes there. We've got 2 answers, so we now need to add them together, which I'm going to do here for you. Starting at this side, 6 add 0 is 6, 6 add 2 is 8, 3 add nothing is 3, 1386. We know that grey is correct. Moving on down, the next one, I can tell you that is correct. 3.72 times 100 is 372. So let's have a look at blue. Blue says 8 with a little 2, add 2 with a little 3 equals, and it's saying 77. Now the little 2 here we know means squared, i.e. you times it by itself. And the cubed we looked at yesterday is where you times it by itself and then times it by itself again. So let's do the first one, 8 squared. So 8 squared means 8 times 8, which is 64. 2 cubed is 2 times 2 times 2. Well, 2 times 2 is 4, and 4 times 2 is 8. So we have 64, add 8. Well, if I add 6 to that, it's 70, 2 left over, 72. So, blue is one of our imposters. Possibly the only one, we'll see. Moving on, we have purple. Purple, we have 7 over 9, 7 ninths, add a third. 7 ninths, add a third. Now, we can't add these fractions because the denominators are not the same. So, let's change one of them. Well, we're lucky today because 3 goes into 9, so we only need to change one of them. So we can change that third into something over 9. 3 times 3 is 9. So 1 times 3, because we do the same to the top. And now we add them together. 7 plus 3 is 10. We don't add the denominators. 10 over 9, which is the same as 1 and 1/9. So purple is correct. Next one is orange. 324 divided by 12 Going to do bus stop method for this. So we've got 12 into 324. 12 doesn't go into 3. We put 0 and carry it. 12 goes into 32. Well, 12, 24. So that's twice. With how many left over? Well, I got to 24, but I wanted 32, so it must be 8. And 12 into 84 goes 7 times. So 27. Yep, orange is correct. Next one then. 4,309,220 equals 4 million. Add 300,000, yes. Add 9,000, yes. Add 200, yes. Add 20. So that's correct. Green, 544 divided by 4 is 126. Okay, bus stop method again. So we've got how many 4s go into 544? Like so. 4 goes into 5 once, carry the 1. 4 goes into 14, well it goes 3 times, which is 12, so 3 times. 12, I wanted 14, so that's 2 left over. 4 goes into 24, 6 times, 136. So based on that then, green is wrong. Let's just double check, make sure I've not gone wrong. Yep. 4 goes into that with 1 left over. 4 goes into 14 3 times, because 4 times 3 is 12 with 2. Yep, 136. So green is the imposter as well. Okay, 2 imposters down. Let's keep going. The next one is 3/7 times 7 is 21 over 7. That is correct, because if we had 7 lots of 3, it would be 21. So that's fine. The next one then, 42,397. 397. Notice how I'm checking there that I'm writing it down correctly, because that's one of the common mistakes people make, is they write it down wrong from here to here, or from anywhere from the board to your maths books when you're in school. Take away 2,632. Okay. Starting at this side, 7 take away 2 is 5. That's fine. 9 take away 3 is 6. 3 take away 6 we can't do. So we're going to borrow from here. Now we've got 13 take away 6. Well, 13 take away 6 is 7. 1 take away 2 we can't do, so we borrow from here. 11 take away 2. We struggle to do a 9 upside down. Nah, I'll do. And 3 take away nothing is 3. So we've got 39,765, which is different to that. So pink's an imposter as well. And finally, 726 times 0, easy, is 0, because anything times 0 is 0. All right then. Let's move on. We start as we always do. Which one of these on the board doesn't belong? So we have a representation here of a grid, 100 squares. We have a percentage, a fraction, and a decimal. Pause the video, work out which one doesn't belong. Off you go. Okay, so this one here, we've got 10, 20, 30, 35 out of 100. So we've got 35 out of 100. Now, if we've got 35 out of 100, we know that would be the same as 35%, because it's the numerator. And it'd be the same as 0.35. 0.35, 35%, 35 over 100. Okay, so 35%, well, that's here, so we know that's the same. 0.35, that's here, so we know that's the same. So this one here, 35 over 50, is the odd one out. Here's a bonus question for you then. 35 over 50, what would that be as a percentage? See if you can work it out. Pause the video. Okay, so 35 over 50, we can't really turn it into a fraction, into a percentage at the moment, because it's over 50. And if you remember the golden rule, to easily get a percentage, we need it to be over 100. So we take the 100, and we need to turn that 50 into that 100. We do that by timesing by 2. What we do to the bottom, we do to the top. 35 times 2 is 70. 70 over 100 would be 70%. At this point, I'd just like to say as well, the answers you submitted on Seesaw yesterday, particularly for those of you that did activity 5, which I asked you to put online, were absolutely fantastic. You gave a really good explanation. It was a bit similar to this, where you had to double it up to make it a fraction over 100. So well done. Okay. So, on to today then. We are still comparing fractions, decimals and percentages, but we're dealing with some slightly trickier ones. Now, if we have a look at this display here, we have the fractions, the decimals and the percentages. It's given you some of them, and it's asking you to work out the others. So, this one here, well, is nice and easy. It's asking us for the fraction. Now, if we've got a decimal of 0.25, the fraction would be something over 100. Well, what would it be? Well, we know, if we look at the top one, that it would have to be 25, because if you look at the top one here, 0.45, 45%, 45 over 100. That 45 part stays the same as long as it's over 100. So we 0.25 would be 25 over 100. The next one down, we've got 0.49. Well, again, that's nice and easy. We can make that 49%. And 49 over 100. Now that's interesting. You notice how they took the 25 over 100, they simplified it down to the smallest fraction. And that's something I'd like you to have a go at, please, if you can. Make it as small as possible with the fraction. The next one here is 2/5. And it's asking us for a decimal and a percentage. Now, because it's over 5 at the moment, that's quite hard to turn into a decimal or a percentage. So we're going to take it, we could make it over 100, but that would be more effort than we need to put in. I'm going to put it into something over 10, because I can see that I can go from 5 to 10 easily by doubling it. What I do to the bottom, I do to the top. So 2 would double to make 4. If I've got 4 out of 10 there, if I've got 4 out of 10, I know that that would have to be 40%. 40%. Because it's 4 out of 10, which is the same as 40 out of 100. So anything over 10, we can also use to make a percentage. But you need to remember to put that 0 on the end. I didn't say that because I'm not allowed to say that. I meant to explain it mathematically. But basically, if it's over 10, put a 0 on the end when you're working out your percentage. Okay, lovely. Now, moving on. Hopefully I'm proved right. I am. Lovely. The next one is 0.03. Now, 0.03. I'm going to show you 2 possible answers for this. I want you to tell me which one is the correct one and which one is the common mistake that people make. So, we've got 0.03, which would be that, which would be that. Then we've got 0.3, which would be that, which would be that. So I've got two possible answers here. The top one is 30 over 100 is the same as 0.03, is the same as 30%. And then the bottom one here, I've got 3 over 100 is the same as 0.03, is the same as 3%. Which one do you think is the correct one? Well, the correct one is here, because for this to be correct, this decimal would need to be 0.3, not 0.03. Because remember, 0.3 is the same as 0.30. We just don't put the 0 in. 0.03 is the same as 3 over 100, which is the same as 3%. And if you look at the one underneath, we've got that trick there for you. 0.3, and they've cancelled it down to 3 over 10, but it would be 30 over 100 as well. 37 over 100 is there. So, activity 1 then, for all of you please, can you have a go at transforming the percentages into decimals or fractions into whatever, or mix them all up and do what you like? Apart from the fact I need you to actually, answer the questions would be great. Thank you very much. Pause the video now. Those of you that are just unpaused got the joy of watching me rub the whiteboard out. Lovely. Let's have a look, see how you got on. Here are your answers. Pause and mark. Okay. So we're moving on now to comparing. We've done our transforming. We're now going to use that transforming and converting to then be able to compare two different fractions, decimals and percentages. And we're going to say which one is the bigger one, or whether they are both worth the same. Now, just to recap, we've got our crocodile symbols here, which, just to make sure you're definitely on the same page as me, crocodile eats the bigger number. So basically, the bigger of the two, the mouth needs to face. Okay? And if it's the same, you put your equal sign. Right, the first one then we're looking at is 11 over 100, something 21%. So we need to be able to compare them. Now, the best way to compare them is to be able to make them both the same. So you're either going to need to choose to make it into both of them a percentage or both of them a fraction. And it really doesn't matter. You choose whichever you prefer. Okay? Whatever you do though, you need to make them the same so then you can look and compare. So if we look at this one here, I'm going to choose to turn it into a percentage. So I'm going to take 11 over 100. Now I know that 11 over 100 is the same as 11%. Well, 11% is smaller than 21%, so that's the way my crocodile symbol is going to go. Okay. Now I'm just going to have a look through, see if there are any on here that I think are particularly challenging before you have a go. So the next one is 7 over 10. Well, 7 over 10, because it's over 10, would be 70%, because it's the same as 70 over 100. Well, 70 is bigger than 43, so it would face that way. 1 over 10 would be 10%, because remember, you might have thought to yourself, it's 1%. No, that would be 1 over 100. 1 over 10 would be 10%. There we are. Now we've got 19% and 0.19. Well, they are actually both the same. Moving over here, I don't see that one being any difficulty. Just remember that 1/5, you would need to turn it into something over 10 to make it easy for you. This one I think would be fine. 50% is the same as a half. And again, 12 over 50, you'd need to double it to make it over 100. And that would be there. So activity 2 then, again, is aimed at all groups, please. Can you have a go at working them out, changing them so they're the same, either percentage, fraction or decimal, and then compare which is the largest. Pause the video now. Okay, let's see how you got on. And here are your answers for you. All right then. Now this time we're looking at shading in the ones that are equivalent. That means the same as, in this case, 20%. So we need to look at each of these one at a time and work out whether they would equal 20%. If they do, we shade it green. If they don't, we don't. So the first one is 40 over 100. Well, that would be 40%, so that's wrong. 0.02, well, that would be 2%, so that's wrong. 40 over 200, well, let's just double check this one, because it's over 200, so I need to make it so it's over 100. I do that by dividing by 2. That would then become 20. Well, that is correct then. So 40 over 200 would be green. 0.2 is the same as 0.20, so that would be green. 2 over 10 is the same as 20 over 100, so that would be 20%. 0.22, no. 2/5, no. 10 over 50, again, it's over 50, not 100, so we need to transform it. 10 over 50 equals something over 100. Well, to get from 50 to 100, we double it, so we do the same to the top. Becomes 20 over 100, which is 20%. So let's see if we got it right. And there we are. All right then, pause the video now for me as a bit of a warm-up. Have a go at the ones at the bottom. So you're looking for the ones that are the same as 25%. Off you go. Okay, let's have a look then. So these are the ones here: 25 over 100, 50 over 200, 0.25, and you just need to remember that a quarter is the same as 25%. Okay, activity 3 then, aimed at all groups please, same as we've just done. Can you have a go at shading in, or if you're doing this in your books, just write them down, the ones that are the equivalent to 40%. Off you go. Okay. So, let's see how we got on. Here are your answers. And here are your answers for the second one. Now, for activity 4, we're going to be looking at what's called a part-whole model. What that means is these two parts here come together to make this. So, I'm going to just talk you through the first part of it and then you can have a go at the next part. So it says 100% is the same as 3/10 and A, but we don't know what A is. Well, if we've got 3/10 add something equals 100%. Well, 3/10 add 7/10 would give me 10/10. 10 over 10. 10 over 10 is the same as 100%. But what this wants you to do is it wants you to give one fraction, one percentage, and one decimal. So you would need to take the 7 over 10 and turn that into a decimal. That would be 0.7. Now, activity 4 is mainly aimed at my group, but if you'd like to have a go, like some of you did yesterday, I saw some fantastic work from children that had a go at activity 5 yesterday. Have a go at completing this part-whole model. Remember, you need one fraction, one decimal, one percentage each time it splits. So you would need one of each here, and you'd need one of each here. Okay? Pause the video, have a go. And here are your answers. Now, there are different combinations you could have answered. They're all here for you. Okay. Now, this is an optional activity for you. Activity 5. Using the number cards below, make as many fractions as you know the equivalent decimals and percentages for. So you could take these and I'm going to take 4 and 5. So I'm going to do 4 over 5. Okay? Now what I'm going to do is I'm going to turn that into a percentage. Well, that would be, if I made that into something over 10, it would be 8 over 10. So that'd be the same as 80%, which is the same as 0.8. And you keep on going, making as many as you can. Aim for 5 if you want to have a go, but say this is an optional activity. Activity 4 was the main one aimed at my group, but please, by all means, have a go at this one if you want to. Right, we look forward to seeing you work on Seesaw. Thank you very much. Speak to you soon. Bye.